Welcome to Petaflick. In this video, you will understand the feature of Python support object-oriented programming. The object-oriented programming contains a concept called class, object, inheritance, polymorphism, encapsulation, and abstraction. A class is a block of code or program. Using a single class, we can create multiple objects. All objects will contain the same functionality developed in the class. The class can be used as a blueprint to create multiple objects for different purposes with the same functionality. The block of code of a class looks like this. A class contains multiple methods and multiple variables. Each method is a code block which contains some variables and logics. Each variable stores some value in the memory. For example, we can assume a class as a mold which contains the design of a specific statue. Using the mold, multiple statues with pin-to-pin similarity can be created. Another example is we can assume a class as a house plan design. Based on a single house plan design, multiple houses can be constructed with pin-to-pin similarity. To make you understand what is an object, I will tell you a real-world practical example. Let's say a design is developed for a new car. The design has all the features of the car. Using this design, can we drive the car? Can we travel from one place to another place? No, it is not possible because we have only the design and we don't have the physical car. First, a physical car should be created based on the design we have, and then we can use the physical car to travel from one place to another place and access its features while driving the car. Here, car is the physical object created based on the design or blueprint of the car. In the same way, class is the design developed with some features. To use the features, the code of the class should be stored in the computer memory. To get some storage allocated for storing the class code in the memory, an object must be created for the specific class. When the object is created for a specific class, the code of the class will be stored in the memory and some memory is allocated for the execution of the logic developed in the class. The memory assigned for an object can be used only by the respective object. No other object created in the memory can access the memory assigned for other objects. By these rules and regulations, each object created has its own dedicated and isolated memory, which other objects cannot access. After the creation of object for the class, we can use the features designed in the class through the object created in the memory. I hope you would have got some understanding about what is an object. Let's assume that this class is created with the addition logic, subtraction logic, multiplication logic, and division logic. Calculator is the name of the class. Add is a method developed in the class to perform the addition of two numbers. Subtract is a method developed to perform subtraction of two numbers. Multiply is a method developed to perform multiplication of two numbers. Divide is a method developed to perform division of two numbers. Now, we have the design of a calculator available as a class. To use this calculator, the class code must be stored in the memory. For the allocation of storage in the memory, we must create an object for the calculator class. To create an object, we must provide a name for the object and the name of the class based on which we want to create the object. The syntax we should use to create an object is object name equal to class name followed by parenthesis. To create an object for calculator class, we should write the code as calculator1 equal to calculator followed by parenthesis. Calculator1 is the object name and calculator is the class name. When this specific code is executed, computer creates an object with the name calculator1 in the memory and a copy of the code from the calculator class is copied into the calculator1 object. Now I hope you got some understanding of what happens when an object is created. Let's understand the scenario of creating multiple objects based on a single class. The programmer is allowed to create multiple objects for the same class in the same program, depends on the requirement. But the name of the object must be unique and should not be duplicated within the program. Let's say four objects are created for the calculator class. What happens internally? The first object will be created with the name calculator 1. The second object will be created with the name calculator 2. The third object will be created with the name calculator 3. The fourth object will be created with the name calculator 4. Finally, a copy of the code from the calculator class will be stored in each of the objects created. All the four objects have their own isolated and dedicated memory. One object cannot access other object's memory even though they are created based on the same class. Every object of calculator class will have all the logics developed in the calculator class. All the four objects created using the calculator class has the add method, subtract method, multiply method, and divide method. To perform the addition of two numbers, the programmer must execute the add method from the object. To execute a specific method from the object, the programmer should follow the syntax as object name dot method name followed by parenthesis. Within the parenthesis, the value should be mentioned separated by comma. For example, when the program executes the code calculator 1 dot add parenthesis within parenthesis 5 comma 3, the add method from the calculator 1 object will be executed. During the execution, the variable x will be replaced with value 5 and variable y will be replaced with value 3. The code x plus y will add the values 5 and 3 and the result 8 will be displayed to the programmer. Based on our requirement and based on the type of calculation we want to do, we can execute the respective method from the object. We can perform addition, subtraction, multiplication, and division of any two numbers using calculator 1 object. Similarly, we can perform addition, subtraction, multiplication, and division of any two numbers using calculator 2 object as well. In the same way, we can perform all these operations using calculator 3 and calculator 4 object as well. By now, I wish you would have got a good understanding of what is an object. Inheritance means all the assets of the parent will automatically go to their children by default. For example, if the parent has a car, all the children of the parent can use the parent's car, and the children of the parent automatically inherit the rights on the assets of the parent. The same concept is developed in object-oriented programming concepts. We can create a class as parent and we can create multiple classes as child classes under the parent class. All the child classes created under the parent class can use all the logic developed in the parent class without the need of rewriting the entire logics again in the child class. Using the inheritance concept, if a specific functionality is already available in some class, we can reuse the existing functionality by inheriting the parent class instead of developing the functionality from the scratch in the child class. To summarize, using the inheritance concepts, if a functionality is already available, we can reuse the existing functionality instead of developing the functionality from the scratch or beginning. The word polymorphism means taking multiple forms by a single person or thing according to the situation. In general, a person will not show a same behavior with all the people in his life. The same person will show different behavior and characteristics with a different people according to the different situation. The same concept is available in polymorphism concept also. Using this concept, we can modify the functionality of a method and make the method to behave differently in different situations. For now, you can think of a method as a block of program code developed inside a class. With the help of polymorphism concept, we can make a single method to work differently with different logics according to our situation and requirement. For example, let's consider a person named John. John plays different roles in his life during his lifetime. Let's understand. John plays the role of a son to his mother and father. John plays the role of a father to his son or daughter. John plays the role of a husband to his wife. John plays the role of an employee in his company. John plays the role of a manager to his team. John plays the role of a grandfather to his grandchildren. What we can observe here is John shows different behavior when talking to his mother and father. John shows different behavior when talking to his son or daughter. John shows different behavior when talking to his wife. John shows different behavior when talking to his company HR. John shows different behavior when talking to his team in the company. John shows different behavior when talking to his grandchildren. From this example, we can understand that the same person is playing different roles in his life and different behaviors towards different people. As there is a possibility of a person or thing to take multiple forms under multiple situations, the same concept is implemented as polymorphism in object oriented programming. Let's say a software is developed to automatically respond to different people involved in the life of John. In programming, the characteristics or behavior of the person or thing are defined using methods inside the class. Class represents John. When the users of the software are John's mother and father, then the software should respond differently as a son. When the users of the software are John's son or daughter, then the software should respond differently as a father. When the user of the software is John's wife, then the software should respond differently as a husband. When the user of the software is John's HR, then the software should respond differently as an employee. When the users of the software are John's company team, then the software should respond differently as a manager. When the users of the software are John's grandchildren, then the software should respond differently as a grandfather. In object oriented programming, different behaviors are provided to the same method using the concept of method overriding and method overloading. Using encapsulation concept, the access to confidential information can be restricted to the end users and the data can be protected. Using abstraction, we can hide complex functionalities of the software application from the end user and display only the user-friendly options to the end user. Let's understand the benefits of object-oriented programming. With the help of object-oriented programming concepts, programs can be developed replicating any real-world object like car, bus, pen, school, bank, company, etc. Every software application is developed and needed to store the data of a real-world objects by every business. Softwares are developed keeping a specific domain and the requirement in the specific domain. Software applications are required for every industry to store the data digitally and get the stored data quickly according to the need. For example, a school will approach a software development company to develop a software to store the student data and teachers data and other activities happening in the school. The software for a school should be developed keeping all the possible activities that can happen in the school, considering each student, teacher, and others involved in the school. Another example is a bank will approach a software development company to develop a software to store all the customers' data, branches data, and details of each and every transaction happening in the bank on day-to-day basis. The software for a bank should be developed keeping all the people and things involved in the bank activities like bank employees, bank customers, branches of bank, and money deposited and money withdrawn. Another example is a car manufacturing company will approach a software development company to develop a software to store all the activities happening in the company like how many cars are manufactured, what is the chassis number of each car, how many cars are unsold, and how many cars are sold, to whom the car is sold, etc. The software for a car company should be developed keeping all the possible activities that can happen in the car company, considering the company employees, multiple departments in the company, details of each and every employee in each department, which cars are unsold and available in the showroom, which cars are sold to which customer, etc. Based on these examples, we can understand that every software is developed to store some data and get the stored data about the real world objects existing in the world in our day to day life. To develop a software representing the real world object, the programming language we are planning to use to develop the software must have object oriented programming concepts. Otherwise, we cannot develop the software using the specific programming language. Let's understand some technical benefits of object oriented programming. A software can be entirely developed using a single program file. When the complete code is present in a single program file, for any simple change like either modifying the existing logics or adding new logics, the entire program file must be retested to ensure that the existing functionalities of the application are working fine without any issues and the new functionalities are also working fine. A complete retesting should happen for each and every code of the program, even for minor changes in some part of the code, even though the existing program was already tested for the existing functionalities. The reason is that due to changes in the file, everyone will be doubtful that whether the changes in the program file caused any existing functionality to stop working. Due to having single program file with the entire code, the maintenance of the application will be difficult and adding new features will be difficult and modifying existing features also will be difficult. For every simple change, the entire testing should be conducted again and again, which cause a lot of time consumption by the testing team in the project and a lot of money should be spent for conducting the entire testing. Instead of creating a single big program file for entire software application, the big program file can be split into multiple smaller program files called modules based on the functionality developed. These smaller program files can be interconnected with each other logically with the help of object-oriented programming concepts. When the software is developed with multiple smaller program files, for the modification of the existing features of the software, only the program file or module file which contains the specific functionality should be modified. The testing team primarily focus on the modified files or newly created program files instead of worrying about the program files which are not modified. Anyway, by default, the testing team will test the whole application code for each and every change. But the advantage is that less time is used for the whole application testing and more time is allocated for the modified code testing. In software testing, the testing of whole application functionalities due to any enhancements or changes to the application is called as integrated testing. In the worst case, if any existing functionalities are not working or impacted due to any code change, the programmer and the testing team will be sure that the changes happened only in specific module files and other files are not touched. To fix the bug, the development team and the testing team will primarily focus on the modified program files or new program files instead of worrying about the other program files of the software which are not modified. This approach of developing an entire application with small module files is called modular programming. The maintenance will be easy for the software application developed using modules concept. The code debugging or troubleshooting also will be easy for the modular software application in case of any issues found. Enhancements or adding new features to the modular software application will also be easy. Modular programming can be achieved using object-oriented programming concepts only. There are a lot of other benefits of object-oriented programming, but discussing about all those benefits will make you confused at this beginning stage. Object-oriented programming concepts are advanced concepts. I am not expecting you to understand these concepts in detail now. You will learn about these concepts in detail when object-oriented concepts are covered in the future sessions. For now, I want you to be aware of high-level benefits of object-oriented programming and Python supports object-oriented programming and the object-oriented programming is used to develop software applications based on real-world objects. Thank you for watching this video. If you are happy with the learning in this video, please like and share this video to your friends and relatives who need this learning. Do not forget to subscribe our channel and press the bell icon to get updates on our upcoming videos.